I thought we'd record this session so that you can watch it multiple times if you need to, or come back and look at it, because although the work that we're doing today is not particularly complex, it does use some different features on your CAS calculator that we haven't used before. So we've obviously solved for unknown variables, unknown angles for sine, cosine and tan functions before, but usually they've been functions of an exact value that we could work back to. And so if we set up in our CAS, we'll set up a new document and we'll just put in a calculator. So I could go menu 31 to solve, and I want to solve in this case for tan of x. When does that equal 1.5? The unknown variable that we're looking for is x, so we put in that, hit enter, and we've done that before. And yes, this is written in a little bit of a weird thing, much like what we looked at the other day, where you could put in a k value to work out our period and our asymptotes for tan functions. Here we can substitute in an n value. You don't really worry about it. It's just a general form of an equation, but basically it's saying that you can use that to work out some values. For a little bit more complicated questions like this one over here, when does sine of x equal x over 2? Well, same deal, menu 31, or you can type in solve if you prefer. And I want to solve for when does, let's set up a division statement or a fraction statement, when does x over 2 actually equal sine of x? And once again, just using your solve function, I don't think you'll have any trouble with that. It tells us there are 3 values here. The little warning sign here is saying, look, it's a repeating function. Sinusoidal functions do cycle through, so you'll get more than one answer. But at negative 1.89 radians, at 0 and at 1.89 radians, 3 times when x on 2 equals sine of x. And because it's cyclic, we could add the period to those values and get additional functions further along in the cycle. But I don't think you'll have too many troubles with this. There are some other questions where we get given some data, and I repeatedly keep saying, oh, we learn all this mathematics so that we can solve real world problems. Well, this is trying to simulate a real world problem where someone's recorded some data and they've gone, oh, that's some interesting data. I wonder what it means. The best way to find out what it means is to do a scatter plot. So if I go Control Doc to make a new page, and I want to put in a list and spreadsheets page. So column A here, let's call that our X variable. And I'll go across, and column B, let's call that our Y variable. You can give them whatever logical names make sense to you. And X is pretty easy, 1, 2, 3, 4, and 6. And then I've got to go across and type in my Y values. So I need to be a little bit more careful about that. 2.08, 2.3, 0.49, negative 1.77, and negative, oh, excuse me, 0.49, enter, negative 1.77 and negative 0.96. Okay, given me a spreadsheet. Works very much like an Excel spreadsheet. If I now go Control and Doc and I add in a data and statistics page, it wants to draw a scatter plot. So, all right, what variable should go along my horizontal axis? Logically, our X variable. What should be on our vertical axis? Our Y variable. Oh, when I look at that, that looks a bit like a sine or a cosine curve. It could go like that. Let's have a look. So in statistics, we can do regression. So I'm going to go menu. Actually, it's easier if I do it rather than doing it from here. Go back into my stats page and hit menu and data and, sorry, menu statistics. stat calculations, and all of these are really interesting, but none of them are what we're talking about. We're talking about sinusoidal regression. So I'm going all the way down to sinusoidal, and then it says, okay, where was your X data? Well, we put that in a variable we called X, conveniently. You might have given it a different name. Where's your Y data? Well, we actually called that variable Y in this case too. You can click on the right arrow here and it'll list any variables that you've already got saved in your list and spreadsheet and choose the right one rather than having to type it. Let's have regression equation saved into the function f1 of x. And so I go, okay. And it's now said, oh, if I drag that out a little bit, there's an equation, y equals amplitude times sine of nx plus a horizontal translation plus a vertical translation. And those values are all in our spreadsheet. Okay. Why don't we have a look at a graph of our spreadsheet? So if I go Control Doc and say, I want to see a graph, and see how we've already gone into F2 of X, because if I hit the up arrow key, F1 of X has already got our equation in with this amplitude. If I hit enter, there's our graph. Why don't we tighten up our window? So menu, window. Now we know from our data that we started at 1, so I might do my graph from say -1 in my window to, we went up as high as 6, so I'm going to allow for 7 in my graph. Our biggest value was 2.08, so if I go from say -3 to 3, I'm going to see all of my graph, and we've tightened up our window, and there's the equation. Now, how well has that really fit those data points? Well, if I hit the menu button again, oops. If I hit the tab button and get back into our graphing, and then I hit the menu button, I choose graph entry edit, and we want a scatter plot. It says what variables, and we know what variables they are. They're X and they're Y. It plots those points, and there we go. We can see that that is a pretty damn good fit for that data. So we can be pretty confident looking at this, saying that this equation here is a good fit, and we could use this equation to solve problems that involve this data using our knowledge of circular functions. Now, I know we haven't done regression and the quality of the best fit in our course yet, and we'll look at that at a later point, but at the moment we know how to generate an equation, and now I can use that equation, substitute in different values of X, or solve for various problems using our CAS and this equation to solve problems that involve circular function. My advice to you is, when you get problems like this, if you need some help, watch the video a few times until you get confident using your CAS, and once you've done that, you'll find this works reasonably smoothly.